Hello, this is just to the people who presented here. I don't know if you will be here for the banquet tonight, I hope, because you might have a chance of winning $1,000 as a sponsor, so I would really like to ask you to be there tonight. Otherwise, we cannot over that. Thank you.
I would also like to thank everybody involved with this event. Presenters, people that supported the presenters in the demonstration, particularly the staging crew in the back room. We had this extra time because of that. I was amazed how efficient they've gotten, and I think they've gotten so efficient at this event that maybe next time we can give everybody 6.5 minutes instead of 5. Now's a chance to ask anybody up on stage a question. If you want some clarification or thoughts on how this thing, what they demonstrated is being applied, or maybe how to make this event better next year. So this is your chance, audience. I have a question for EC Electronics. With the bolt screw, is that being used now? I mean, that's a slick device and a neat capability that I can just see lots and lots of uses for.
So we have some testing in heavy industry for monitoring the screws, and we have dedicated algorithms we built into the device. So it means that the device is useful. First step, and I think it can be very easy to connect it to external device to give the very easy interpreted signal. So okay or not okay.
Questions?
Yeah, I have a question for the bridge monitoring system.
Speak loud. Speak loud.
For the bridge monitoring system, I think by Princeton University. When you showed your data, one of the sensors exceeded the threshold.
That's right. Yeah.
And I wonder what was the cause for that.
This is simply because the thresholds were not set, really to show the performance of the structure. The idea was to show that alarming system is working. So if you see the numbers, it was like 12 microstrain or something like this. So it's really small. Okay.
You must have some burning questions. How about the participants? Do they have any comments or questions they want to ask each other or ask the audience? I mean, events like this, we've heard over and over again in PowerPoint how technology, what the status are and the potential is for using it. But events like this, we really get to see it, and it's the next step in transition. And I think it's a very important type of event. Go ahead.
So I have a question for actually several videos, but especially National Instruments. The guy from Mistress. I'm working on sim diagnostic software that will report irregularly to try to reduce the data communications need. And so I'm interested in hearing more about how we might work together to improve your products and mine. Thank you.
Well, I think one of the strategies that we can discuss is precisely how to set up different types of sensors that are very low power, that can actually be constantly monitoring. So whenever a strain, for example, reaches a certain value, that's when you trigger the monitor. And I think probably this will help to all the applications that need low power or have limited power.
Right, I couldn't agree more. On our node that we have, you're able, as I showed, download LabVIEW and run custom code. So I showed a simple threshold where we could just as easily run a model, do some other type of data reduction. And yeah, absolutely, the transmission is where you burn your power. So the more intelligently you can do that, the better.
Any ideas from the audience on how we can make this event better next time, other than giving each presenter more time?
I have a question to everybody who demonstrated today. Seems like every demonstration is focused on one specific type of failure, either a crack or corrosion or something else. But I haven't seen in any of the demonstrations the ability to actually classify and say, yeah, this is this type of failure. Because any failure can actually demonstrate, can actually exhibit itself. A corrosion can look as a crack, and a crack can look as delamination. So unless there is a way to classify the failure and say, this is this type of failure, and then, yeah, this is the extent of the damage, then there will be really no certainty in the results that we're getting. So.
The best research I know in that area was actually came out in the 90s on multi-mode, whatever it is, but it was basically running multiple Kalman filters or state space models simultaneously in parallel, and then selecting the one that had the best fit. Okay, and this was being done by a prof at Wright-Patterson Air Force Base to detect damage in F-16 simulator, I think it was, and where you got maybe half a second to decide whether you need to, whether the aircraft can be saved, or you need to eject the pilot because the aircraft will otherwise be spinning and tumbling so fast that you can't safely eject the pilot.
My demonstration was how to classify two types of damages. So if you could classify matrix cracks in a composite or delamination, and you could quantify both of them. The question is, the future is how to do how probable, like different levels of probability of that, of how big that damage is. But the classification, at least for the specific composites, my paper tomorrow will talk about specifically classifying those two damages present that happen simultaneously. And so. Yeah.
This would be a good start, but I would like to see a global way of looking at the damage in a structure. They actually looking at all types of damage. And also maybe boundary conditions that may affect the results also, or environmental conditions that can affect that.
Right, so the method that I suggested basically runs different models, assuming the different damage conditions, and then selects the best one. And I'm Spencer Graves from Structure Inspection and Monitoring. If you want to send me an email or something later, or contact me later, I'd be happy to give you some references and so forth.
Just to add, the model I have proposed is so generic, and it does not look for damage, it looks for performance, and if performance is not right, then we can look after damage. So why not doing that, and then in the second step we identify which damage we are looking for.
Yeah, one of the wireless, the acoustic emission wireless node is being developed with support of a NIST TIP project, and a big component of that project is precisely modeling for diagnosis and prognosis. There is another whole component of that project in the next 2 years, which are the 2 final years of the project, that is looking at models that are being developed at the University of South Carolina, University of Miami, to actually be embedded into the FPGA on the wireless node, so it will have prognosis capabilities. That's the final objective.
Fault detection and isolation are different words that you want to use.
Okay, so that's what I would like to say is, for example, in the Tacony-Palmyra bridge that we are doing the monitoring, we have a suite of sensors. So it's not just one monitoring system that is supposed to detect one particular type of the damage, but we have dynamic strain gauges, we have dynamic tilt meters, we have weather station to see environmental influences, we have cameras to see the conditions of the traffic, and we monitor the performance. Then we monitor the operational conditions, and we monitor also the safety of the bridge. So there are several layers, and I don't say that there is a magic answer for the moment that can, detect any type of damage in any condition ever. But there is a lot of progress, and I think a lot of researchers here are actually trying to do this, to have, approach that is not focused to. Maybe some of the presentation had, shown one particular thing, but this is not because I think I look at like one of the puzzle pieces that is going to solve the problem.
I may miss on the one.
Sorry, I was just going to address the one more thing. I think I heard you say something also about quantification. One of the things that we showed was really detection of 2 different types of events, one an impact and one damage, and both of them had quantification associated with one magnitude of an impact, and also a quantification of the size of the damage that it had caused.
It is extremely important really to listen to the maintenance department before you start to make research. And in our case, we have heard that it's really not important how many water has entered the flow beam. As we can detect, let's say, 1 milliliter, and this is already too much. They know exactly now we have to take action. This means quantification is a good thing, but not always necessary. You just have a threshold that is passed, and then you have to take action. This is really the demands of the maintenance departments.
Good.
Okay, I may miss one of the key issues. Now, in all the demos, actually one of the key component of the wireless sensor is the power or battery. And I don't think anyone have talked about the energy harvesting of their sensors. So is anyone?
Yeah, again, within the project, the TIP project, the NIST project, we have a big component also is energy harvesting. Small windmills, very, very small windmills, patches that, are under the traffic, and they produce enough power to recharge batteries. So, although it wasn't demonstrated here today because it's not ready yet, there is a big component there because we know that is important. Power is not available everywhere.
Yeah, that's why I like to see next time.
Sure.
More
In 2 years.
More
I promise in 2
energy
years.
You want to?
I agree with the individual that asked the question about power being one of the challenges associated with wireless sensors. I would, though, say that what we demonstrated for the new Carquinez bridge has been in place for almost 2 years now, and have successfully used solar panels. Now, while the size of the solar panels are maybe not as desirable, they're sufficient to allow for other power harvesting technologies to sort of catch up, if you will, technologically, to offer alternatives. But in my opinion, there are some viable power harvesting technologies that are there that do allow you to go for long periods of time unattended without having to replace batteries. Now, ultimately, most power harvesting technologies, you still will have to replace batteries due to fatigue of recharging batteries. So even power harvesting technologies are not a perfect solution, but I think there's a lot of promise there.
But I think some people,
some
people are really using the environment. They try to measure or try to sense. They're using the environment to create energy.
Yeah, but that is true. Similar to the project at Mitras. Our project is also looking at vibration-based power harvesters, mini wind turbine harvesters. But as I mentioned before, many of those technologies are not sufficiently mature, at least for application in civil infrastructure systems. One of the challenges with vibration harvesters, for example, is you're generally looking at low frequency, low amplitudes, which is very undesirable for vibration-based. We're also looking at RF harvesters, beaming wireless energy, if you will, to the sensor. But as I mentioned before, these technologies are still under their R&D phases in the laboratory, and will need some time to reach a level of maturity that they can be viably used with reliability in the field.
Yeah, that's an important question that we need to continue to address. Do you have one last comment? Because I want to wrap this up.
Yes, in fact, just you show the big variety of the different research going on at this workshop. We have some sensors, among a few other papers by other researchers, developing passive wired sensors. It's called passive, it's because it does not need any battery at all on board. It's a completely passive device. It gets all the energy, I think Professor Lynch just mentioned that from an RFID reader, the reader beams all the energy to the sensor, and the sensor gets all the energy from the reader this way, wirelessly, and then reflects energy back to the reader. So from this reflected energy, it could sense string or some other quantities. So there are quite a few papers at this workshop on this topic, if you're interested.
Okay, thank you. Let me try to wrap this up. We all got a very nice dinner event with some cocktails facing us in about an hour and a half. And we can continue discussions there with the panelists, the demonstrators, and the people in the audience. I would like to thank Airbus and the IWSHM committee who's sponsoring the awards, and they will be announced during the dinner. Okay, so stay tuned, show up, it's a great dinner. I would like to thank those sponsors, and I would like to thank the panelists again, or the demonstrators. And I'd like to thank the audience for hanging in there.
May I ask one short question? I think the demonstrations that was done today collectively make a very good case for SHM in the future. And having this on tape or a CD or something can help present the case to whoever is still skeptical about how SHM can work in the future. So I wonder if this CD will be available at a certain point to the audience.
Well, that's a good question. Are we going to have a video of this available someplace? On a website?
YouTube. YouTube.
Thank you.
And thank you for that question. You're all dismissed, and we'll see you at dinner. Thank you.